You do it hundreds, maybe thousands of times a day. You click a link, and it feels like nothing, right? It's just instantaneous. But that one little click, it sets off one of the most incredible high-speed ballets of engineering on the entire planet. Today, we're going to pull back the curtain on networking basics.
I mean, have you ever really stopped and thought about it? What is actually happening behind the screen in that split second? What kind of journey does your request go on? From your phone or your laptop, out across the world and back again, all in less time than it takes you to blink?
Well, it's a crazy fast trip across a massive global web of computers. So for this explainer, that's exactly what we're going to do. We're going to follow the data from that one single click, and we're going to trace its path step by step to see how this whole thing actually works.
Okay, so first things first, for any message to get from point A to point B, it needs an address. You can kind of think of the internet as a giant worldwide postal service. Every single device connected to it needs its own unique address to be found.
And probably the easiest way to wrap your head around this is with a simple analogy. Think of an IP address as the street address for a big apartment building. It gets the mail, the data, to the right building. But once it's there, how does it know which apartment to go to? That's where ports come in. A port is like the specific apartment number, making sure the data gets to the right application, whether that's your web browser, your email client, or your online game.
So to get a little more technical, an IP or Internet Protocol address is just that unique numerical label that's given to every single device on a network. It's literally how computers find each other. That string of numbers right there, a perfect example of a digital street address.
And that port number? That's the final destination. It's all thanks to ports that you can be streaming a movie on port 443 while you're also downloading an email on another port, all using the exact same internet connection and the same IP address. It's kind of the internet's secret to multitasking.
All right, so we know that every website, every server, has a numerical IP address. But we don't type a bunch of numbers into our browser, do we? We type names, like example.com. So how does that work? Well, this brings us to what is essentially the internet's phone book.
Exactly. You type in a name your brain can remember, but your computer has no clue where that is. It needs that numerical IP address to send a request. So, the very first thing that happens on this journey is a lookup. It has to go find the right number. And this giant magic phone book is called the DNS, the Domain Name System. It's a massive distributed directory for the whole internet. Your computer just asks the DNS, hey, what's the IP address for example.com? And DNS shoots back the right number. And this step is absolutely critical. Without it, the journey can't even begin. Okay, so now our computer has the address. It's ready to send the message. But it doesn't just, shout the request into the void and hope for the best. It follows a very specific and, I'd say pretty polite, set of rules to make sure the message gets there safe and sound.
This whole conversation happens in 4 key steps. We've already done step 1, the DNS lookup. Next, the two computers have to formally introduce themselves and agree to talk. Then they create a secure, private channel, and only then do they actually ask for the web page. Let's break down those handshakes.
The next part is the TCP handshake. TCP stands for Transmission Control Protocol, and its entire job is to be reliable. So before sending any real data, your computer pings the server and says, hey, you there? The server replies, yep, I'm here and I'm listening, and your computer says, awesome, I'm about to send something. This little 3-way chat makes sure the connection is solid.
Only after that introduction is complete do we finally send the HTTP request. HTTP is the Hypertext Transfer Protocol, and this is the actual message. Most of the time, it's what we call a GET request, which is basically your browser saying, please get me all the content for the website I want to see.
Now, here's something that's kind of mind-blowing. All of this, the lookup, the handshakes, it all happens before a single pixel of the website even starts to load. This upfront time cost is called latency. And as you can see, that invisible delay is spent on the DNS lookup, the TCP handshake, and an extra handshake for security.
If you add it all up, on average, it takes about 330 milliseconds. That's about the same time it takes you to blink your eyes. A third of a second just vanishes, gone, just getting ready to receive the website. Yeah, it's incredibly fast, but it is far from instantaneous.
But of course, this journey doesn't always go off without a hitch. We've all been there, right? You click a link and nothing. The page just won't load or your app refuses to connect. So what's actually going wrong? Well, let's look at some of the most common ways this can break down.
So, a few common culprits can totally derail this whole process. A DNS failure? That's like the phone book having a typo. The website might as well not exist. A misconfigured firewall is like a bouncer at a club who's blocking people for no reason. You can even have weird issues where the data packets are too big for one part of the network, so they just get dropped without a word, or where peer-to-peer apps, like for gaming, can't figure out how to talk to each other directly. These are the glitches behind all those frustrating connection errors.
But the good news is the internet is constantly being upgraded to be faster, more reliable, and a whole lot safer. Engineers have come up with some brilliant ways to optimize this journey and get around those common problems.
Yeah, we're always making the trip better. We use things called content delivery networks, or CDNs, which are like local warehouses for websites, storing copies of content physically closer to you so it loads way faster. The protocols themselves are getting smarter, too. New ones like Quick can actually combine the connection and security handshakes into one step, slashing that initial delay. And of course, there's security. That's where TLS, or Transport Layer Security, comes into play. It's the gold standard for encrypting your data and wrapping it in a private shield so nobody can snoop on it during its journey.
And this quote right here, it makes a really important point. For a long time, security like TLS was bolted on to the existing internet protocols. It was an add-on, not something that was part of the original design from the very beginning.
But that is changing. Right now, there is a huge push to build security in from the ground up. We're seeing concepts like zero trust networking, which basically assumes no connection is safe by default, become the new standard. We're even encrypting the DNS lookup itself, which hides that initial phone book search so nobody can see which websites you're trying to visit. The goal is to make the entire network secure by default, not just as an afterthought.
So, when you boil it all down, every single click is this incredibly complex dance between three things: speed, reliability, and security. And sometimes, making one better can affect the others. As the world gets more and more connected, the big question for all of us is, how do we find the right balance? Which one will you prioritize?